Continuing with circles, gonna keep talking about properties of chords. So as I look at this one, I see, okay, in the same circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So because in this problem, I'm given that AB is congruent to CD, then I know that their corresponding minor arcs out here are also going to be congruent. So arc AB is going to be congruent to arc CD because their corresponding chords are congruent. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So because I have this right angle here, because the problem tells me that this is a right angle, I know that the only way that these lines become a right angle is if this line is congruent to this line over here. And then therefore AB, which is right here, AB is congruent to CD because these are going to be the same chords as long as EF is equal to EG. So if they tell me numbers, if they tell me that there's this right angle, then I can go ahead and I know I can assume that then AB is congruent to CD. So let's put that into practice. Use the diagram BD, or use the diagram of circle D to find if the measure of arc AB equals 110 degrees, find the measure of BC, arc BC. So I'm going to highlight AB. I'm going to say, all right, AB is 110. That's going to be right here. All right. And then we are looking for BC. We're going to make that orange. BC over here. Well, one thing that we can notice is that I've got AB is equal to 9, and I've got BC equal to 9. And we just talked about, well, if their chords are the same, then their arcs are also going to be the same. Well, if I see that arc AB is 110, then I can go ahead and also say that BC is going to be 110 because these two arcs have to be exactly the same. If measure of angle AC equals 150, if the measure of angle AC equals 150, so this is kind of a different problem. All right, find the measure of arc AB, which would be over here. So in this one, I would say, well, I'd still use that same idea, and I'm going to say, all right, well, whatever AB is, I also know that CB is going to be the same thing. And I know that at the end of the day, everything's got to equal 360. So I've got 150 plus whatever this is, I'm going to call it X. And because it's the same thing over here, I'm going to say plus X plus X. Really, it's like saying 2X. And now I can just go ahead and solve this. I'm going to subtract 150 and get 210, and then divide by 2 and get X equal to 105. So what would the measure of angle AB in the second problem would be 105. So again, problem 1 and 2 are different, but their thinking is that, hey, if I know what's left, I can definitely figure out what else I have by just process of elimination and taking what I know and figuring out what I don't know. Okay, in the diagram of circle C, QR equals ST equals 16, find CU. So this is like the second example here where if these lines turn out to be congruent, then we know that they are equidistant from the center. So because the directions told us right here that, hey, these lines are the same, boom, boom, sweet. Well, guess what? That also means that these two lines are the same. And so I'm going to go ahead and say 2x equals 5x minus 9. Set it equal to each other. Negative 3x equals negative 9. And x is going to equal positive 3. So that gives me x, but the question asked for CU, which 2 times 3 gives me 6. So CU equals 6. Let's check our work. 5 times 3 minus 9. 15 minus 9 still equals 6. If I plug it in here, I get the same answer. Okay, if one chord is perpendicular bisector of another chord, then the first chord is a diameter. Basically saying that if I've got a chord and it gets evenly split into two, well, in order to do that, you would have had to go through the center. And diameters always go through the center. So again, just more properties, more things that when we know one thing to be true, we can assume, we can differentiate a lot of other things that are true. And again, you know that if it's perpendicular, then you can say that it bisects it because, again, it's going through the center at a 90 degrees angle. So use the diagram of E to find the length of AC. All right, well, right here, if I know that this side is 7, they're going to be the same. This side is 7. Therefore, AC is 14. And I would have used... I think I would have used 10.4. I would use 10.4 on that one. All right.